All right, guys, last lesson for Unit 1. After this, you should be able to find the derivative of anything. So, which is one of the main big ideas in calculus. Now, we're not done with derivatives because we got 2 other chapters to spend on them where we kind of talk about what they mean more and also how they're used more. But you now have the skill of finding the derivative of everything after today's lesson. So today we're talking about finding the derivative of an inverse function, right? So we're just doing derivatives of inverses today. So it might be helpful for us to understand what an inverse function is. We've talked about it twice now in this unit. But 2 functions, f and g, are inverses if f of a equals b when g of b equals a. Okay? So in other words, the inputs and the outputs get swapped. We would call them inverses. Now graphically that's interesting because if you take the x and y values and switch them, they will always look like they've been directly reflected across this diagonal vertical line, which I think we've mentioned before in this chapter as well. The symbol for for an inverse is f with a little -1. It's not an exponent, okay? It looks like one, but it's not, because f is not a number, so it's a concept. So f is the name of the function. So the name of your function with a little -1 in the upper right-hand corner indicates that this is an inverse function. You're changing the name. All right? So you could say that g is f inverse of x. I see a lot of pencils moving. This one's printed, isn't it?
Yeah.
Am I missing anything on the notes? Huh?
There's just a little blank.
Oh, there's blanks. Okay. I'll wait a minute then.
There's only like one little.
You guys are good?
Take your time, Scott. Take your time.
All right. So we got what an inverse is and what they look like. All right. So if you found all the points that exist for one function and connected them together, you get a line, right? And if you reflected all of those points across that dotted line, you get a pretty cool little symmetrical situation going on here. Second here, I want to pause. Okay, so let's talk about slopes for a second here. Let's take a look at this guy. Now, as you guys know, that the slope of the tangent line is your instantaneous rate of change at a particular point, right? So let's talk about the slope of the line on top there. It's rise over run, right? So we go over so much and up so much. We go up y and over x. You guys good with that? But over here, the x's and y's have been switched. So do you guys know what the slope would be of this line? Close x over y. Since the y's and the x's get switched in inverses, there's your difference. So the slope, but here's something to pay attention to. It's kind of easy to miss. Well, let's call this point AB. What's this point over here then? BA. So this is the slope of the f function at x equals a. This is the slope of the inverse function at x equals b. Okay? So there's your interesting relationship, okay, between the slope of a function and its slope of its inverse. It's that the slopes are reciprocals at the opposite points, if you will. So if the slope of this function at a is y over x, then the slope of its inverse at b will be x over y. Okay? So basically all the x's and y's get switched. The b and the a get switched, and the x and the y, the rise and the run get switched. So there you go. That's that. So that's the relationship between a function slope and the slope of its inverse. That's how they're related. So we're going to kind of draw that relationship out with a few examples here. Okay. Did I print these examples for you? Okay. So I don't think I really want you guys to write these down. I just want you guys to participate with me in completing the exercise, okay? So here we go. Let's take a look here. Who knows what goes in the blanks for part A? Raise your hand if you think you know what goes in the blanks for part A. Jimmy?
Is it X and Y?
True. Can you be more specific? It is X and Y.
F of X equals Y?
No, but I'm still going to give you a point. Jimmy Pinedo. You're right. You're right. But yet, I'm looking for, how about this, Jimmy? I'm looking for some numbers.
Oh, 27?
There you go. What do I put in the parentheses? 3 or 7?
7.
3. You had a 50-50 on that, right? So the X goes in the parentheses, right? The 7 goes here. Now let's take a look. This is the F function, and this point is on the F function, right? So the X goes here, the Y goes here. But let's take a look at the inverse. This is the inverse function. You guys see how it's like a reflection through this dotted line? My next question is going to be thrown out to you. Can somebody tell me what that point would be, Mateo?
7, 3.
It would be 7, 3. You guys agree? The X's and Y's get swapped. So now I'm going to ask you raise your hand. You know what goes in here?
Yeah.
What goes here?
7.
7 does. So you guys see that? F of 3 equals 7 if F inverse of 7 equals 3. Okay? All right. So I think I put like a thing on here. Let me see. I did. All right, you guys see the tangent line I just threw up there? Do you see it? Okay. So according to my new little addition here, F prime of 3 equals 4. Can somebody tell me what that means? Yes, Matt? Good. You almost have a complete statement. He needs more information to make that a full sentence. But he said the instantaneous rate of change is 4. What are we missing? At 3. It's just 3. It's not 0.3. So the instantaneous rate of change at x equals 3 is 4. Right? All right. So the instantaneous rate of change at x equals 3 is 4. So drum roll. You can have 2 points if you fill this one in for me. Someone raise their hand and tell me. Yeah?
Is it 7 and then 1 on that?
Uh-huh.
And then the other one is 1, 4.
Oh my gosh! You're fine, dude! Nobody else is excited as me. My heart skipped a beat, bro. All right, so yes, if f prime of 3 equals 4, then the inverse's derivative at 7 will be the reciprocal of that slope, which is 1/4. So then f inverse prime of 7 would be 1/4. Nice job. So that's how they're related. Kind of complicated, right? Switching things around. Let's do another one. All right, I'm gonna let you guys think about this one here. Yeah, okay. So my red line is f, it's down here. My blue line is f inverse, it's on the top. Okay, so don't shout out this time. I'm not gonna take hands this time. I'm gonna use my cards. I want you to think for a minute about what you're gonna put in part A, and then I'm gonna call on you. All right, Angelina Yanez, are you ready? What do you put in here?
6.
And 3, right? Good. So that's our first one. Okay, think about the next one, part B. I want to know what goes here. You're going to draw it? I'll slap you. I didn't want you guys to draw this. What's this point going to be? Yeah. Good. And therefore, this is 3 and this is 6, right? Easy enough. All right. Now drum roll time. I want you guys to, well, I need to give you information first. Ready? Darn it. Okay. Darn it. Huh. All right, I'm going to change this then. This is f inverse prime of 3 equals 2. I kind of goofed up there. So I'm giving you the slope of the inverse function here at x equals 3 is 2. I want you guys to fill in this blank. Then f prime of what equals what? So go ahead and see if you can figure that out. So if the instantaneous rate of change at 3 is 2 on the inverse function, then the instantaneous rate of change at not 3, right, 6, is the reciprocal of that, just 1/2. All right, let's do another one. Feeling cozy yet? Yep. Weird. All right, I'm gonna bring up. All right, I'm gonna say that this red function here is f. So this is f up here, and then down here we're gonna call this blue function f inverse of x, which is technically not true because that's not a function. It fails the horizontal line test, but vertical line test. But we're good. We'll pretend it is. Doesn't matter. Go ahead and fill in all these blanks.
It's 2, 3.4, 3.4, 2, and then 2 is 2 or 3.
Close.
No, it's 3.4 and 2.
Good. So we have the idea, right? So the point is that if the slope of your function at this x value is such and such, then the slope of the inverse function at the other number as an x value will be its reciprocal. Okay, so that's how inverse functions work. We have another one, but I feel like you guys probably got this. How many of you guys feel like you need one more shot at this? How many of you guys feel like you need one more shot at it? No? Okay. Well, we'll go ahead and let that go then. All right, so now this is where we're going to bring in the symbols, and the symbols are confusing because it's another language, but really it's just the math way of saying everything that we just said. Okay? So let's analyze this carefully. Ready? F of A equals B. You guys agree?
Yeah.
That's just a given. Therefore, doesn't this make sense? They're just switched, right? That's what inverses do. That means that the derivative of the inverse at B, right, is the reciprocal of the derivative of f at A. Does that make sense? No.
Yeah.
Okay, let's back up. Let's back up. Go back to our slides here. So we just did this one, right? So you guys agree that the derivative of the inverse at 3.4, right, was the reciprocal of the derivative of f at the other number, right? Okay, so let's go back to this now. So if f of A equals B and f inverse of B equals A, then the slope of the inverse at B is the reciprocal of the other function's slope at the other number. Okay? And now to make it even more confusing, What does A equal? So I can replace A with, and get this even uglier expression. Okay, so you can remember the derivative of an inverse then in two different ways. I don't know which way is going to stick, so we'll see. All right, you can remember that the derivative of an inverse is the reciprocal of the derivative of the other function at the other number. Or you can just memorize that formula down there in the bottom. So whatever you like. But that's how you find the derivative of an inverse. Take some pondering. Why don't you guys stare at that for a little while. Connect it. Now, in the last slide, we didn't have A and B. We had 2 and 3 point. We can't spend too long on this. I just realized we got to kind of hurry up. But we had 2 and 3.4 and 3.4 and 2, right? Okay. So I'm calling A 2, and I'm calling B 3.4. So the slope of the inverse function at 3.4 is the reciprocal. That's what 1 over means, right? Is the reciprocal of the other function's slope at, what's A? 2. Now, if we were to plug in 3.4 here for B, what's F inverse of 3.4? It's 2, which is the same thing as this. And what was our function slope at 2 on the last slide? Wasn't it 3/2? And the reciprocal of that would be, if you do 1 over that, you get 2/3. Finally. So let's leave the formulas as they are. We'll ponder it some more maybe on our own time. But for now, let's go ahead and start applying this stuff. So find example 2. First of all, I want you guys to know how to do this. So just as a quick review for you, suppose I asked you guys to find for me G inverse of 2. If I asked you guys to find for me G inverse of 2. Well, inverses are confusing, so let's think of it as its opposite function, the original one. If G inverse of 2 equals question mark, then G of question mark equals 2. So we're going to look in the G column for a 2. You guys see it? What's the X value that goes with that? 1. So here's how these things work, you guys. When you're doing inverse functions, this number will be in the G column, not in the X column. You know, usually how we start by looking in the X column and go over to the G. Well, when you're doing inverses, you do the opposite. You start into the G and you go over to the X because you're working backwards. Okay? So let's do another one. See if you guys can figure out what this would be. What's F inverse of 3? See if you can figure that out. We haven't even started the calculus part yet. We're just kind of front-loading how to read the table with inverses. We'll get to 1 and 2 in a minute. All right, so check your answer with a neighbor. Walter, what'd you get? 2 is correct. Let's do another one. I'm just going to, you don't have to write these down if you don't want to, but G inverse of 1. See if you guys can figure out what that is. G inverse of 1. Tornado. Are you doing your math? Jimmy. Bro, really? Oh my goodness. All right, Michael, what did you get, bud? G inverse of 1 is 2 again. Good. All right, let's do one more. How about F inverse of 2? 2. One more. What do you think, Matthew? It is 3. All right, so that's 3 for 3. I'm feeling like you guys know how to read that. Now, this is a little bit more confusing. I wouldn't want you guys to think that means we're going to go to the 2 in the prime category. It doesn't work that way. We're going to have to use the formula, okay? So, G inverse, start writing this because this is number 1. G inverse prime of 2 is equal to 1 over, now the formula is G prime of G inverse 2. That's our formula we copied down the last slide, right? So, what is G inverse of 2? Let's do that first. G inverse of 2 is 1. You guys good? And then 1 over G prime of 1. What's G prime of 1? And so my final answer is -1. Okay, so we start with the formula, right? And then we simplify. Okay, write down number 2. I want you guys to see if you can start by writing the formula out for it. Write your formula out for number 2. Okay. So Andrew, I'll get you started here. It's going to be 1 over what?
F prime
Times
F inverse of 3.
Very good. Okay. I'm going to now figure out what's F inverse of 3. So go ahead and do that. I'm going to call on you, share that out in a minute. F inverse of 3. Nicholas, what'd you get for that?
You got
2. Next, we got to do this. F prime of 2. Orion.
3.
F prime of 2 is 1/2. And we have 1 over 1/2. Caitlin, what's that going to be? 2 is correct. So this, just so you guys know, you could do this a long way and multiply the top and the bottom by 2, right? Cancel the 2's out and end up with 2 over 1. Or you could just know this means reciprocal, right? So whatever you put down here is just going to end up flipped over. It's going to be 2. So if you had 2/3, it would be 3/2 or something, right? All right, so that's how you do that. I don't want you guys, even though we're using the formula, I want the formula to make sense, though. So the slope of an inverse function is the reciprocal of the slope of the other function at the other number. Kind of a weird statement, but there you go. All right, so go ahead and try those 2. Amanda, what did you get for number 1? -1. How many of you guys got -1? It's probably -1. All right, let's go ahead and do number 2. Zarina, what did you get for number 2? 2. How many of you guys got 2? So it's probably 2. I'll still work them out just in case you guys are wondering. But so we have G inverse prime of 1 is the reciprocal of the derivative of not the inverse at the opposite of 1. right? And so that's 1 over g prime of, well, g inverse of 1 would be 3, and then g prime of 3 would be -1. And so I agree, it is -1. Crazy, huh? Let's do the last one here. We have f inverse prime of 1 is going to be, so the derivative of f inverse is the reciprocal of the opposite of the inverse, which is just the original function's derivative, at the opposite of 1. So that would be f inverse of 1. Okay? So f inverse of 1, f inverse of 1 would be 2, and f prime of 2 would be 1/2. So we have 1 over 1/2 again, which is 2. The reciprocal of 1/2 is 2. Crazy stuff. So it seems chill now, and it can stay chill if you practice. But the problem is, this formula really sucks to remember. So you kind of really like, it took me a while to get it too. I think what you really just need to remember is that the prime is on the outside and the inverse is on the inside. Because when you later, like a month from now, when you try to remember this, you're probably you'll be tempted to do this probably, just because it's like a 50-50 guess. Okay, so you got to get that formula right. It's the prime on the outside, -1 on the inside. All right, so here's a really, if you want to feel prime on the outside, keep your negative crap on the inside. Is that a positive way to live your life? All right, just kidding. That's obviously bad psychology. But it helps you remember math, so it's good. All right, let's go ahead and write down number 3. Write down number 3. If you want to look prime on the outside, keep your negative crap on the inside. You'll never forget it now. See what I've done? That's called teacher stuff. All right. So this is very convoluted and confusing looking. So let's read it and understand it. We've got a function. We have that function's inverse here, and they're renaming it. So they're going to call the inverse of fg. So down here, when they ask for g prime of -6, they're really asking for f inverse prime of -6. That makes sense? So g is f inverse. You guys good? I don't know why they do that, but they do. All right. Then they're telling us that f of -1 equals -6. Okay? All right. So we've got a function. We're renaming the inverse as g. And they've given us a point on the graph of f. Our job is going to be to find g prime of -6. So first things first. G prime of -6 is the same thing as what prime of -6? G, well, let me start. G is the same thing as what? F inverse, right? So if G prime of -6, then F inverse prime of -6. So I'm going to rewrite it as an inverse, because that's what it is. Don't you guys agree? If G equals F inverse, then G prime of -6 is F inverse prime of -6. You guys good? And why would I do that? Because now we can do our formula. If you want to feel prime on the outside, then keep your negative crap on the inside. Okay? Okay. So, we're going to simplify this now. What does F inverse of -6 equal? -1. I'll still show my work, but you don't have to do this. So if F inverse of -6 equals blank, then F of blank equals -6. And we know what F of blank equals -6 would be. It would be -1. So this piece up here equals -1. You guys good? You can draw a little arrow to here if you want. All right. 1 over F prime of negative 1. How can I find f prime of negative 1? Huh? Close. Don't plug it into the original, but plug it into the what of the original? The derivative of the original. So I've got f, right? So what's f prime of x going to be equal to? 2x plus 4. So what's f prime of negative 1 going to be? 2. So then my final answer is 1 over what? 2. Yeah, what's up, Neha? No, I just did. Let's move on. I'm sorry, go ahead, dear. What's up?
The one that's hard to get as higher than one.
Oh, I didn't show my work because I didn't have much space, but you can and you should if that was confusing to you. So you understand how I found f prime, right? Are you sure? It's the derivative of this. Okay, now why did I do that? Because I want f prime of negative 1. So the first thing I did was I found f prime, right? Now I'm going to plug negative 1 into here. So if you do that, f prime of negative 1 would be 2 times negative 1 plus 4. And 2 times negative 1 is negative 2, plus 4 is 2. I just didn't show my work for calculating. All right, so there's your steps, right? Now, I'm going to give you an example just like this. Okay, so therefore you can follow my steps and probably get the right answer. The problem is that the way these questions can be asked is so many ways. Here's what's really important. You need to know that formula. That's really important. From there, you just got to think your way through it, right? So, like this whole thing about G, that's new. Okay, so they're going to rename the inverse with another letter. That's fine. Okay, we'll do that. So we're just going to go back to what we know then. And then from there, we do our formula. That's the real meat and potatoes. From there, you got to think about it. We had to figure out that that was negative 1. And then we had to figure out how do you get f prime of negative 1, right? So there you go. Every problem's different, but the one I'm going to give you is very similar to this one. You guys ready? There you go. Try to do it without looking at the example. Try to think your way through this problem because your homework tonight, they won't all be set up like this. Some will, but not all. And so understand it, read it, look at what they're saying, and then what's the one thing you make sure you need to get in there at some point? That formula, the inverse formula. That's got to happen sometime. Okay, the rest of it, think your way through it. See if you can figure it out. A good answer here. So first of all, we have G prime of negative 5 would be the same thing as F inverse of negative 5. And prime, sorry. And according to our derivative formula, we want to look prime on the outside, so we keep our negative crap on the inside. And if F inverse of negative 5 is what we want, then the number it's going to equal is going to be 1. So we want f prime of 1, which means I need to find the derivative of this and plug in 1. And there you have it. Hey, Caleb. All right. Yeah, sure. Bye.